Thank you so much to Holly for creating this challenge for us. So we've got 3 different inputs that we can see over here on the left. We've got our available stock in our different stores. We've got our different products associated with those product IDs, and we've got our supplier data here, so we know our supplier name based on their supplier ID. So we can just join the product IDs together and join the supplier IDs together, and then just get rid of any of those joining fields that we don't need. So we have a data set that looks a little something like this. So now to come to the analysis part of it, where we're kind of thinking about when those reorders are happening, the times when more stock is ordered. So any time that we see basically this quantity available being less than or equal to 10, that's when a new order has been placed. So let's just write a quick calculation so we can help easily identify those rows. So we're saying that the stock is ordered when the quantity available is less than or equal to 10, and that gives us a true or false field there. Now we need to know the number that is ordered in those times. So any time that this is true, then we know that the order is basically 30 minus this quantity available. So in the case where the quantity available is 10, it means that 20 products are then ordered to get us up to a 30 level. So that's all we're doing there. We're just making sure that if that stock ordered is true, then we do 30 minus that quantity available. Lovely. And then to work out the quantity sold, it's a little bit more tricky because we've kind of got to work across multiple rows here. So if we weren't dealing with the fact that we had the reordering, it would kind of just be a simple, we take the row above and we minus from it the row below. That would give us 5 in this example here. So we go from having 21 items available to 16 items available. That means we've sold 5, right? But then when we have times when we're ordering more quantity, then we know that we have to first do the quantity available, add the quantity ordered, and then minus off this value here. So for example, in this week it would be 18 that were sold instead of, well, it doesn't make sense for it to go from 10 to 2, we sold minus 2. So yeah, that's what we're trying to do in this example. So as I've explained it there, I think I probably could have done this with one fewer calculations, but I kind of broke it up for myself. So I did the previous week quantity available, so using that lookup function, so partitioning on each store and each product, ordering by the inventory date in ascending order, and looking up the previous quantity available. So for this top row here, we can see that we've got our quantity available being 3, the previous week's quantity available is 8, so that just gets it on the same row for us to be able to work with that. And then similarly, if there was quantity ordered, then we just want the previous week's version of that, so we know how many that happens. I mean, other ways that we could have done that, I guess we always know that it's going up to 30 if there is quantity ordered. So if we kind of just looked at the previous row and saw if that stock ordered field was true, then we would know that that would be 30. But hey, this is the way that I chose to do it. Maybe you chose to do it differently, and that's okay. There's often multiple ways to calculate things. So just writing our calculation here. The main part is this part here, where we add together those 2 previous calculations that we just calculated here. So the previous week quantity available, the previous week quantity ordered, and then minus from that the quantity available for that current week. That will tell us how many were sold in that week. And we only want that to be true and to happen if there are values in these fields that we have looked up the previous values for. So where it's null in both of these fields, don't do anything, just keep that as a null. So that stops us from selling minus numbers of products, which is good. We don't want to have those values in our data set. Cool. And then in order to calculate the kind of order frequency, I thought it would be easiest to assign basically any time that an order has happened, that restock has happened, it gets a 1 on that row. So literally just saying if that stock ordered is true, then give it a 1, else give it a 0. So I could sum that up in the next step to count how many orders were made for each of those products across the weeks of data that we have in this data set. So in our aggregate step, we are grouping by the store, grouping by the category, grouping by the product. We are taking the total number of rows, as that's the total number of weeks in the data set. I wasn't sure if there might be variation across different stores and products, but no, it looks like every single store and product in this data set has 14 weeks worth of data. And then we're summing up that total orders that we made there. So for example, for this one, we can see that there were only 3 orders made in those 14 weeks for this store and product combination. And then we're just totaling up that quantity sold. I did debate here, I was like, should we do an average at this stage, or should we do the sum and then divide it by the number of weeks? And I think that in this case, I saw that it was giving me a different result if I did one or the other, and I think that's because of that null value that we've given it in the previous kind of step here. So it isn't including that in our calculation. If we do an average here, it just kind of ignores the null. So I want it to kind of still be counting the fact that there are 14 weeks worth of data. So yeah, that's why I chose to do it as a total quantity sold here. Plus we want that in the output as well. So for the average quantity sold per week, I did the quantity sold divided by the number of rows, rounding that to 1 decimal place, so I get that average quantity there. And then for the average order frequency, I did the number of rows divided by the total orders. So this time the other way around, so that rather than that value, for example, in the top row here, we've got that there are 7 total orders and 14 weeks in the data. If I did 7 divided by 14, I get 0.5, and I don't really know what that means frequency-wise. I kind of want this to make sense. So this 2 means that there is an order placed once every 2 weeks. So that makes a lot more sense to me to see personally. And then just doing a little bit of renaming, a little bit of removing fields, and we end up at this point. Going back to the average quantity sold, actually, just to touch on that again, let's find a quantity sold that is going to be easiest for us to think about. So this 142 there, if I did that as an average in my aggregate step rather than a sum, then that was coming out at 10.9. Whereas dividing that by 14 is coming out at 10.1. So that's an example where I think that, yeah, it makes more sense to do it this way to calculate that average rather than in the aggregate step for those null rows where I assume it was dividing by 13 instead. So we don't want it to be doing that for us. Cool, so that is the output for this challenge. Thanks very much to Holly again for designing it, and thank you very much for watching.